Alright, figure 4 we have here. Want to try and find theta up here. We're given this angle. So we have pretty much two angles in it. Looks like a law of sines to me. With two angles, I'm usually going with law of sines. You have this, so it's going to be the sine of our unknown angle, the sine of theta, over its opposite side, 19. That ratio will always be the same as the sine of the other angles over their opposite sides. So sine of theta over 19 will be the same ratio as sine of 22 degrees over its opposite side of 8. And that's the way we always set up the law of sines. You can't flip it. Some people say, I'll do 19 over the sine of theta equals 8 over the sine of 22. Doesn't matter, because once we cross multiply, we're going to get the same thing. When we do this, right here, the means extremes property, 8 times the sine of theta, 8 times the sine of theta will equal these multiplied, 19 times the sine of 22 degrees. Now, don't sit here and do that yet. Just let's go ahead and we're trying to get theta by itself. So let's isolate the sine of theta. So to get rid of multiplying by 8, I'm going to divide by 8. Those will go away. Divide this side by 8. And now I'll get the sine of theta is approximately, I'm going to do this division, 19 times sine 22 divided by 8. When I did it, I got 0.8896906, blah, 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 blah. Now, I got to get theta by itself. The way we undo sine is we take the inverse sine. Whenever we're trying to find an angle, we're always going to be doing an inverse sine, inverse cosine, inverse tangent, whatever. That's how we always get theta by itself. Since I want to get rid of the word sine, I'm going to do the inverse sine. That gets rid of it. I'm left with theta by itself. And my calculator, when I do the inverse sine of 0.8896906, blah, 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 I get about 62.8 degrees. And that's what theta would be in this problem for figure 4.